Welcome back, pre-calculus students. In order to help us solve solve exponential equations, we're going to use something called the uniqueness property. The uniqueness property says for any numbers m, n, and b, where b is greater than 0, as long as your base is greater than 0 and doesn't equal 1, if we can say that b to the m equals b to the n, that means that m has to equal n. That's what the uniqueness property means. Any base taken any exponent, if it's equal to that same base taken a different exponent, they have to be equal to each other. This can help because it allows us to solve certain problems by rewriting in terms of different bases. For example, 3 to the 2x minus 5 can equal, we're going to rewrite 9 with a different base, in this case with the base of 3. We're going to say 3 to the, well, to get to 9, we square it. That means that 2x minus 5 has to equal 2 in order for this exponential equation to work, which means that 2x has to equal 7, x has to equal 7 halves. Sometimes we need to mess with the bases just a little bit. In this case, 8 and 4. Don't be fooled and try and divide by 2. We got to get down to the same base. What I would say is the common base between 8 and 4 is 2. So we can take 2 cubed to get it to 8, just as we can take 2 squared to get to 4. Now we can use some of our rules of exponents to say if an exponent to an exponent will be the same thing as multiplying those. So 2 to the 3 times x will equal 2 to the, distribute this 2, 6x minus 12. The uniqueness principle now tells us that 3x will equal 6x minus 12, negative 3x equals negative 12, and x equals positive 4. Finally, we may need to combine a couple of our different rules. For example, in this case, a base of 3 and a base of 3, we're going to rewrite 27 with the base of 3. 3 squared times 3 to the x equals 3 cubed will get us to 27 to the 5th power. That's 3 to the 2 plus x will equal 3 to the 15th, which means, again, the uniqueness principle can tell us that 2 plus x will equal 15, and that x equals 13.